In this example, a scale is to be calibrated by weighting a 1000 gram test weight 60 times. The 60 scale reading have a mean of 1006 grams and a standard deviation of 2 grams. Schematically, let's draw it in a line. So we have the 1000 value and we have our sample mean equal to 1006. Now, what is the sample telling us? That the mean is on 1006 and the standard deviation is 6 grams. So it's telling us that it's not calibrated because it's not 1000. Okay. What we like to know is the scale calibrated or not? So because the sample is telling us that it's not calibrated, that's the alternative hypothesis that we want to test. We are going to assume that the population is 1000 and the null hypothesis is that is calibrated. So the null hypothesis will be just this value, the H0. So the alternative hypothesis is not calibrated. It will be around those two regions. So this is H1 and this is H1. Now, H0 assumes that 1000 is the mean and X is just a random variation of the mean. So therefore is calibrated. So we need to start to compute the C value for X. Notice that as a difference from the previous example, we have the alternative hypothesis at both sides of the null hypothesis, and that the null hypothesis is an equality. C of the mean is equal to 1006 minus 1000 divided 0.258, which is the standard deviation divided by the square root of 60, the number of samples, and this is equal to 2.32. We can go into the table and compute the probability of C less than 2.32 and is equal to 0.9898. Now, the value that we really need is the complement of this value. Assuming that the mean, which is the null hypothesis, is equal to 1000, the value on the right that we want to compute, the mean, is equal to 1006, that in terms of C is equal to 2.32, and the probability that we want to compute is this tail probability, the probability that X is larger than 1006. So that probability is equal to 1 minus 0.9898, which is equal to 0.0102. Now remember that the null probability specifies that mu is equal to 1000. It's an equality, and because it's an equality, we should consider also both directions around the mean. That means that we need to compute this value, which is 1000 minus 0.6, so that will be 999.4, or this is equivalent to minus C, and this probability, it will be equal to this probability. So the p-value for this particular problem is given by the two tail probabilities. So it's 2 times 0.0102, which is equal to 0.0204. Now this p-value is less than 5%. So it's a small value. So meaning that the probability that the mean is 1000 and 1006 is a random variation is very small. Therefore, the evidence against the null probability is very strong. So therefore, the alternative hypothesis is true, and the alternative hypothesis is that it is not calibrated. In summary, the evidence against H0 is very strong, and therefore H1 is true, meaning that it is not calibrated.